So in this module of the workshop tutorial, we are going to go over the client interface first. We'll follow that up with the initial state of the routing table as seen in the Quagga interface. First off, this is the RPKI login window. As we saw in the end of the installation module, we're going to log in as lab user 08. And the password for it is also lab user 08. If there are multiple people walking through this demo, each user can use the lab user accounts. They are numbered 00 through 16. We'll use number 8 for purposes of today's demo. As you can see, once I've logged in as lab user 8, we have the following screen. This is the home screen for the lab user. This is the home screen for any account, actually. And it contains a number of things that we'll walk through. First off, there's the resources section in the top left-hand corner. This shows us the resources that have been allocated to us. In my case, the lab user 08 has been allocated the 192.168.8.0/24 block. And these resources were allocated by my parent, which is the workshop. If you recall, in our architecture diagram, the fake IANA handed resources to the workshop holder, and the workshop holder has handed resources to each of the lab users. In this case, lab user 08 has been handed their resources by workshop. There's also some unallocated resources on the right-hand side. Note that unallocated resources mean that there is no ROA for it yet, and we'll go over how to create ROAs soon. You can see that our entire block is currently unallocated. The resources match the unallocated sections. Over here on the left, we would have a list of ROAs if we'd created any, but we haven't yet. And as a reminder, ROA stands for Route Origination Authorization, i.e., which ASN has legitimate authority to advertise a route to that address block from their ASN number. And over here, there is a Create button if you would like to create one. This Create button and this Create button can both create ROAs for you. This one's a little bit special because it's filling in the form for you, knowing that this is the unallocated resource that you want to manipulate. There's also Ghostbuster records. These were a reference to the 1984 film Ghostbusters for who you're going to call. One nice thing about the RPKI system, it provides a mechanism to allow operators to provide contact information for their network address blocks. The Ghostbuster record will let us do that in the future. There's also router certificate requests. We won't be using router certificates in our demonstration, but in a future module we may. If we had any children, they would be listed here, and we'll log into the parent workshop account in the near future. We'll see that lab user 08 is a child of the workshop. Under parents, you can see who our direct parent is. Our direct parent is the workshop, and they also have a repository, which is where the workshop publishes all of their data. There's also a menu in the upper left-hand corner. We won't go over these in detail at the moment, but note that we actually are on the dashboard. If I click on it, that actually takes us to this page. That's a quick way to get back to this page if you're never quite sure where you are. If we want to click on the parent, we can do so by clicking Workshop. It'll tell us some more information about the parent, including the service URI and other various bits of information. So now let me log out of the lab user account, and we'll log in as the root account. The root account lets us switch between all of the different users easily. The root account password is RPKI Workshop. Here you can now see that we have a list of people that we're allowed to become. For example, I can click into lab user 08 and it will show us a screen just as if we had logged in as lab user 08, with the exception that we have this logged in as root note up at the top. On the left, we also can go to select identity. That gets us back to this list that we can change. So I'm going to shift to the workshop account. So as the workshop user, you can now see that IANA has allocated 192.168.0.0/16 to the workshop account. And from that, I have a bunch of unallocated resources, specifically everything from .17.0 up through the remainder of the ./16 has not yet been allocated. 192.168.16 and lower has been allocated to the lab users, which you can now see are in our children list as we expected from 01 to 16. The rest of the interface should look pretty similar to the lab user 08 identity. Note that the parent of the workshop is the IANA handle. And we can actually select a new identity and go in as IANA and see that IANA has all of the resources. But as you can see, our fake IANA also has a bunch of unallocated resources as well. But let us shift now to looking at the Quagga interface on what the current routing validity state looks like. As a refresher, remember that our network architecture had the following structure. Specifically, the two parent routers, B0 and B1, are the routers that are actually advertising the space on behalf of the children. So the routers prefixed with the letter R actually hold the address space, but the 2B routers are actually doing the BGP announcements. All of the routers are listening to the BGP table, so we can log into any one of them to determine the status of the whole system, which we will do now. So I can SSH to R8 at Trusty, and remember that the password is Fnord, F-N-O-R-D, and it's going to ask us for the Quagga password as well, which is F-N-O-R-D. And now at the prompt, I can type the Quagga commands. So the first thing that I want to do is show that if we look at show BGP neighbors, note that we have one neighbor at 10.0.3.10. And if I continue on, our second neighbor is at 10.0.3.11, and their AS number is in here as well. More importantly, let's look at the BGP summary. Show IP BGP. In this very long table, we have a list of all of the routes being seen as well as their status. I'll briefly go over what each thing in the rows mean. So first off, there's an identity. That's the unique Quagga key. There is the status of the routing. We'll get to that in a minute. There is a network block. So you can see that each of the network blocks is listed, .0, .1, .2, and what the next hop is along the path. In every case, .10 and .11 are the next hop, as those are the addresses of the B0 and B1 routers. Finally, there's also a metric and a path. In this case, the path is a single item. It is the upstream B0 and B1 router. Remember that those are ASNs 33 and 34. And then finally, the trailing I indicates that it's IGP, as we are in the private address space for purposes of the demo. Let's go back to the validation status. The validation status actually has a couple of components, and N indicates not found. And there are actually two internal components of this. The first N indicates the RPKI status, and whether the RPKI system that we have been studying has found a ROA for this address space and whether it is valid or invalid. In this case, the N means it is not found because the system is starting from a steady state where no ROAs exist, with the exception of .1 actually has a invalid and a valid state. We'll come back on how to get to that state, but you can look at .1 as an example. So the second part of the status is actually the path-based security, in other words BGPsec, and whether it considers it valid or invalid. We're not doing BGPsec on the system today for our purposes, so this will always be a dash indicating it's not currently enabled. The RPKI status is what we want to look at for the remainder of this demonstration. When the RPKI has found a ROA for an address block, say the 192.168.1.0 block, it will have found, hopefully, only valid entries indicated by a V. As you can see in this case, there is also an invalid entry, which means that ASN 65534 in this case is advertising a route for this address block, but there is no ROA for it, therefore it is invalid, or that a ROA was found, but it's actually invalid. The only legitimate route that a router should prefer, if not accept, should be from a valid block. Most routing policies, at least in the early days of the RPKI, will allow a not found route through, because it would mean that there is no RPKI instantiation for that particular address block, and that operator has not yet created a ROA for their own address space to authorize it. So in conclusion, for this overview, we have shown what the routing table looks like and its validation status. You can see that it's actually quite long, and it goes all the way down to .16. And we've also gone over what the RPKI.net interface looks like and how to navigate around it. In the next module, we'll create some rows and we'll see what effect it has on the system.